Hello. If you're brazing metals, flux is a vital part of the process. Lucas-Milhaupt provides fluxes for every application, including high temperature and low temperature, furnace and induction brazing, plus automated flux applications. Now, you may be familiar with our Handy Flux product. It's been an industry standard for over 70 years. Flux is a chemical compound applied to the joint surfaces before brazing. It can be brushed on as a paste, or it may be applied by dipping or dispensing as production quantities increase. There are four functions of flux. First, flux protects the base metal and filler metal from oxygen during heating. Oxides must be prevented from forming, or they'll inhibit the brazing filler metal from wetting and bonding to the surfaces. A coating of flux on the joint area, however, will shield the surfaces from air, preventing oxide formation. The second function of flux is to dissolve and absorb any oxides that form during heating or were not completely removed in the cleaning process. This will ensure cleanliness of the base metal surface and filler metal. Third, flux helps the filler metal to flow by reducing surface tension. These three functions of flux provide a surface clean and free of oxide contamination that allows the filler metal to wet, flow, and bond to the surface. In addition, flux serves as a temperature indicator. As the flux is heated, physical changes in the flux appearance can assist the operator in determining the temperature of the part and seeing that the heat is uniformly or evenly applied. Let's talk about what happens at each critical stage as flux is heated. There are 4 stages of flux. At 212 degrees Fahrenheit, the water boils off. It's important not to heat the flux too fast, or the boiling action of the water may displace the flux from the joint area. This would result in no flux cover. At 600 degrees Fahrenheit, the flux becomes white and puffy. This is a good time to pay attention to the heating pattern on the part by observing that the changes in flux are uniform. This indicates even heat transfer across the components. At 800 degrees Fahrenheit, the flux begins to spread out across the base material surface and has a cloudy appearance. The flux is now covering the part and is acting as a protective blanket, inhibiting oxygen from getting to the surface and forming detrimental oxides. At 1100 degrees Fahrenheit, the flux is completely liquid and clear like water. Through the clear flux, a bright metal surface is observed. The flux is now chemically active and is removing residual oxides, preparing a clean surface for the brazed filler metal to wet. Understanding the functions of flux and the stages of flux during heat application will help you achieve strong joints in your manufacturing process. For more information on the use of flux in your brazing process, please visit our website or contact your Lucas-Milhaupt representative. Thank you.